that?
What is
Ah,
BE, Victor?
it's binding energy. He's binding me.
What do we need it for?
Binding energy is there to hold the nucleus of an atom together. Say these two are protons. They're both positively charged. Therefore, they should repel each other, like this. But, because of binding energy, they are able to join together and hug each other like this.
Sometimes we find unstable nuclei. In nuclear fission, the nucleus of an atom will decide to split to two different nuclei of two completely different elements, becoming more stable. In this example, uranium-235 captures a low-speed neutron, becomes unstable, and splits. When talking about nuclear fusion and nuclear fission, there are two terms used: daughter nuclei and the parent nucleus. In this case, uranium-235 becomes unstable and splits into the daughter nuclei from the parent nucleus. Nuclear fission can take place due to multiple factors. In this case, uranium-235 captures a neutron, becomes unstable, and therefore splits. Other nuclei can become unstable due to other things such as the capture of a proton or alpha particle.
The higher the binding energy of a nucleus, the more stable it is, because the harder it is for the protons to get away from each other and thus split into different nuclei.
When talking about nuclear fission, we mainly talk about the chain reaction. For instance, the uranium-235 splits in order to become more stable. In the process, two new stable nuclei are formed, and the energy is released alongside with three neutrons.
The newly released neutrons, if traveling at the right speed, will be captured by other uranium-235 nuclei, and therefore the splitting will undergo once again and the chain reaction is formed.
In nuclear fusion, two smaller nuclei join together to make a bigger one. But because both nuclei have positive charges, they will repel each other. In order for them not to repel each other and get into the binding energy of a nucleus, they have to move at extremely high speeds, like this.
As we can see here, the nuclei are positively charged, and therefore they repel each other. As Victor mentioned before, in order for them to break the repulsion, they have to be traveling at extremely high speed. When they travel at extremely high speed, they get caught up in the new parent nuclei's binding energy.
Sorry, he meant nucleus, not nuclei. Even though nuclear fusion is still undergoing a lot of research, nuclear fission already does have many uses, including the generation of energy through the chain reaction. Nuclear power stations use the energy released from the splitting of the nucleus to boil water. This turns a turbine, which turns a generator. This helps us produce electricity.
Nuclear fission can also be used in the production of nuclear bombs. When a nucleus splits, as mentioned before, it releases energy. Because a nuclear bomb consists of a chain reaction, a massive amount of energy is released. This energy is what we see in nuclear explosions.
As the two nuclei travel at extremely high speed, they get past the repulsion of the opposite charge. Therefore, they get caught up in the larger nuclei's energy,
Binding energy.
binding energy, as Daniel just mentioned, and therefore they can join together, resulting up in a large nuclei, and therefore extremely large energy.